Hello, this is Gina Piscatelli with a lecture for Anatomy and Physiology 1 on spinal nerves. In this lecture, we will examine the anatomy of spinal nerves as well as their function and look a little bit at the components of spinal nerves. First, let's just recall what we already know about spinal nerves, and that is that there are 8 paired cervical spinal nerves, 12 paired thoracic spinal nerves, 5 paired lumbar spinal nerves, and 5 pairs of sacral spinal nerves. We also know that the spinal nerves are named cervical, thoracic, lumbar, sacral, and 1, 2, 3, 4, whatever, based on the vertebral level from which the nerve emerges. Now, most spinal nerve names match the name of the vertebra that's above it. For example, if we look at the second lumbar spinal nerve right here, it emerges out of the vertebral canal beneath L2, lumbar 2. So that makes sense that it's lumbar, the second lumbar spinal nerve. However, things aren't so simple when you get up to the cervical region, because there are 8 cervical nerves and only 7 cervical vertebrae. So if we look at the 4th cervical nerve right here, notice that it comes out beneath cervical vertebra number 3. So that's because there's 8. So there's one on top, and then the last one right here emerges beneath C7, but it's called the 8th cervical nerve because there's 8 of them. Spinal nerves, all of them, carry both motor and sensory impulses. So that's something else that we already knew, and we can review the components of a spinal nerve that I've got a ring around right here. There is dendrites of sensory neurons coming into the spinal cord. Those are located within a spinal nerve, so dendrites. And there are axons of motor neurons traveling in a spinal nerve. So there's axons, right? So there's both motor and sensory here in this spinal nerve. Now, spinal nerves are really quite short, technically, because they split into rami, or 2 ramuses, but they're actually called rami, pretty quickly. So here is where we have the dorsal root ganglion, and we also have the ventral root, and they merge, and they may not be merged until after the ganglion, somewhere around here, even though they're covered in a nice connective tissue together. But the merging really happens here. So this is a spinal nerve right there. It's pretty short. But now the neurons divide up depending upon where they're going to or coming from. And so there's one branch that goes posteriorly, and we call that a ramus, posterior ramus. And there's one branch that it looks like it goes pretty lateral, but we're going to see a picture later that shows that it comes around to the anterior part of the body. So anyway, it's an anterior ramus. Okay. So the information that we're going to see in both rami, both the posterior and the anterior rami, includes somatic sensory from the skin, from skeletal muscles, like their state, their condition, are they contracted or relaxed, joints, like positional sorts of sensory information. Both rami also contain motor skeletal muscle, 2 skeletal muscles, so that's somatic motor. And both rami contain visceral motor neurons, which will be going to smooth muscle or involuntary muscle, and glands throughout the body. That leaves one kind of information that I didn't mention, visceral sensory. So how is that going to get up to like the brainstem, for example? Will it be carried in a spinal nerve or what? Well, it will go through the spinal cord, definitely. But sometimes the sensory neuron goes right to the brainstem. So I'm showing you here that visceral sensory information, like the state of smooth muscle contraction in the bladder, okay, has special neurons that are called sympathetic neurons. We'll talk about when we do the autonomic nervous system. And these sympathetic neurons are going to connect with spinal nerves through this structure that we're going to talk about much later, but it's called a communicating ramus. And there's something known as the sympathetic chain. So that visceral sensory information will come in here, and it might go up through the spinal cord, or there's a number of different routes depending on where you are in the body. So for now, the information that you will find in both the posterior and the anterior rami are motor and sensory, somatic, and visceral motor. So the anterior ramus, let's start with the anterior ramus. It's going to carry information to or from the skin and muscles of the trunk that are positioned in the anterior part of the trunk and the lateral part of the trunk. So the anterior ramus comes off and it comes anterior like this, and it does branch a little bit, but it comes to the lateral side and the anterior side. Also, the anterior rami of certain spinal nerves will give rise to nerves that go to skeletal muscles in the arms and the legs. The posterior ramus carries information to and from the skin and muscles of the back. So the posterior ramus is right there. So let's look at the cutaneous innervation, skin innervation by both rami on an enlarged picture. So a spinal nerve emerges and it splits right away into a posterior ramus and an anterior ramus. The posterior ramus is going posteriorly, no big surprise, traveling to the muscle or carrying in sensory information from the skin to the spinal cord. The anterior ramus emerges from the spinal nerve and it comes out laterally and it gives off some branches to the skin and to the muscles of the trunk. And it continues to come anterior where it also gives out some branches. This is the sternum right here. Now the anterior rami are quite interesting because they form plexuses, that networks. They merge and then they come apart, and then they merge and they come apart. I'll show you a picture in just a second. So a nerve plexus is a combination of many anterior rami spinal nerves. So there are 4 nerve plexuses. There's the cervical plexus, the brachial plexus, the lumbar plexus, and the sacral plexus. No thoracic spinal nerves form any kind of plexus. So only, well, I shouldn't say that, T1 does. It's part of the brachial plexus. But there is no thoracic plexus. T2 through T12 does not form any kind of plexus. Now remember, these plexuses are mergings of spinal nerves, but just the anterior rami, not the posterior rami. So we're going to look at a picture of first the cervical plexus. The cervical plexus is formed by 5 anterior rami of C1, C2, C3, C4, and C5. And you can see how the anterior ramus has some branches that come this way and then this way. and then the fibers get all networked together. So there's axons that might loop around in funny ways, and there's structures that could easily be innervated by more than one of these cervical anterior rami. In fact, one particular nerve that comes off of this cervical plexus is the phrenic nerve. It's right here, and it's going to move inferiorly in the thoracic cavity to innervate the diaphragm, travel inferiorly. But if you trace it backwards, you see that, well, it's got components probably of C5, C4, C3, and who knows, maybe even C2, right? C2 could come in here. So the cervical plexus is C1 through C5, and we typically see that the phrenic nerve is formed from just C3 to C5. So these three anterior rami cervical nerves contribute fibers to the phrenic nerve, which innervates the diaphragm, which contracts when you inhale. Breathe. Okay, let's look at the next plexus, the brachial plexus. The brachial plexus is formed by anterior rami from cervical nerve 4, cervical 5, cervical 6, cervical 7, cervical 8, and then T1. And you can see there's quite a network, and fibers can cross, merge, then diverge, come back together, go apart. But ultimately there's two nerves that I think are important for you, going into healthcare anyway, that emerge from the brachial plexus. That's the radial nerve and the ulnar nerve. So the radial nerve controls muscles in the arm and the forearm on the back side, the posterior side. So like your triceps muscle. The ulnar nerve innervates muscles in the anterior forearm and controls movements of the wrist. So ulnar and radial nerve both come off of the brachial plexus. There is another nerve that's kind of important that comes off of the brachial plexus, and that's the musculocutaneous nerve, and it innervates the biceps brachii. So this muscle right here. And we'll study that muscle in lab. Now we'll look at the lumbar plexus. Again, the lumbar plexus is formed by anterior rami of spinal nerves L1 through L5. So fibers cross, merge, converge, diverge, right? And ultimately will innervate structures in the hip and the leg. Okay, both. And we aren't going to name any of those right now. But you've probably heard of the sciatic nerve, so I thought I would bring this up. The last plexus, the sacral plexus, formed by anterior rami of L4 through S4, contribute fibers to a nerve that most of us have heard of called the sciatic nerve. The sciatic nerve has fibers from L4, L5, S1, S2, and probably from S3. Now, as the sciatic nerve leaves the vertebral canal, it exits this pelvis posteriorly through that narrow outlet behind the hip and then travels inferiorly towards the popliteal region where it diverges. And it diverges into two nerves called the common fibular and the tibial nerves. Now, you've probably heard of people that have had sciatic pain, and sometimes they feel it right, in the butt or in the hamstring. Sometimes the pain is localized right here. But this anatomical connection all the way down to the heel and the foot and the calf explains why there may be pain way down here as well. Okay, way down in the lower half of the limb. So the significance of the fact that there are plexuses of spinal nerves, at least in terms of motor function, is that most muscles in the upper limb and the lower limbs have innervation from more than one spinal nerve root. So if you had damage to one spinal cord segment, a small segment, the limb muscle won't be paralyzed. For example, the biceps brachii is innervated by a nerve that gets fibers from cervical 5 through cervical 7 spinal nerves. The diaphragm, which is really important, gets is innervated by the phrenic nerve, which gets fibers from spinal nerve cervical 3 through cervical 5. There's also a significance to sensory function. These nerve plexuses contribute to an issue with sensory function. So one is simply that the joints are innervated by the same nerves that innervate muscles that move that joint. So that's nice, even though they might be in different locations. So, for example, the knee joint is controlled by muscles above it and below it, right? But the same nerve has fibers that innervate both. But more important, I think, is this sensory component of the skin, or maybe even visceral sensory, but sensory of the skin. And that is that the skin, a certain region of the skin, is innervated by many different nerves. Okay, 3 typically, maybe more. And therefore, if you just anesthetize a single spinal nerve, you won't cause numbness in the skin anywhere because of the overlap. We do know kind of what parts of the skin are innervated by different sensory neurons. We know the map. So remember, the face is by a cranial nerve 5. But the rest of the skin receives sensory or sends sensory input to spinal nerves. So the back of the head, the front of the arm, that's all cervical. The back of the arm, the trunk, that's thoracic. The hip and the front of the leg, lumbar, sacral, the back of the hip and the back of the leg. But it's recommended that you actually need to anesthetize 3 adjoining spinal nerves to produce a complete loss of sensation in one of these skin segments. Now, these skin segments are called dermatomes. So it's a specific area of the skin that gives input to spinal nerves. So let's say, for example, you wanted to numb the region of the clavicle, the skin there. You would want to numb C4, C5, and T1, for example. Some of this might be familiar if you've heard of referred pain, because there's networks of plexuses, and you can get pain that feels like it's in one location, but it actually originated in another. But this dermatome map explains why it's important to anesthetize more than just a little tiny part of one specific spinal nerve. And it could vary a little bit from person to person as well. Thank you very much, and that's the end of this lecture.